Hello students, welcome back to our class. In this module we are going to discuss about objective type questions from the chapter Quadratic Equations. Let us see the problems given here. The very first problem is, if the discriminant of a quadratic equation is 0, then its roots are dash and dash. Discriminant of quadratic equation is indicated by delta, which is equal to b square minus 4ac. For the quadratic equation ax square plus bx plus c is equal to 0. If this is the quadratic equation, then the discriminant of the quadratic equation is delta is equal to b square minus 4ac. I am telling you again, if the value of b square minus 4ac is any positive quantity, means positive number, it means if it is greater than 0. If it is greater than 0, then the roots are said to be real and unequal. Real and unequal, that is real and distinct, when b square minus 4ac is greater than 0. Suppose if the value of b square minus 4ac is negative, negative is nothing but what? Less than 0 numbers, then the roots are going to be not real roots. Roots are non-real. Non-real roots are nothing but what do you call them? They are said to be imaginary roots. So imaginary roots are non-real roots. Non-real roots are imaginary when delta is equal to b square minus 4ac, which is negative. If the value of b square minus 4ac is equal to 0, b square minus 4ac is equal to 0, then the roots are said to be real and equal. What do you call them? Real and equal roots when b square minus 4ac is equal to 0. So please do remember about nature of the roots of the quadratic equation b square minus 4ac is equal to delta. Delta is the indication for the discriminant of the quadratic equation ax square plus bx plus c equal to 0. Now coming to the problem, if the discriminant of a quadratic equation is 0, means what? Delta is equal to b square minus 4ac is equal to 0, then the roots are dash and dash. What is that dash and dash? Real and equal. So you are supposed to write here real and equal roots. You understand? So please do remember this. Coming to the next one, a polynomial of degree 2 is called dash polynomial. So here you can write as second degree polynomial. Second degree polynomial, or the special name for the second degree polynomial is what? Is said to be a quadratic polynomial also. Second degree polynomial or a quadratic polynomial. That is what when degree of the polynomial is equal to 2. Right? Coming to the next problem. Alpha comma beta are the roots of x square plus bx plus c is equal to 0. Alpha comma beta are the roots of f of x is equal to x square plus bx plus c is equal to 0. Then, and alpha plus h comma beta plus h are the roots of x square plus qx plus r is equal to 0. Then the value of h is equal to what? See here, this is the quadratic equation whose zeros are alpha and beta, or whose roots are alpha and beta. Then you will have to find out the quadratic equation whose roots are alpha plus h and beta plus h. Whose roots are alpha plus h and beta plus h. It means if you just observe here, the roots are increased by h. Roots are increased by h, then the quadratic equation will become f of x minus h. F of x minus h, because the roots are increased by h. If the roots are increased by h, that of the roots of f of x is equal to 0 is f of x minus h. So substitute x minus h in the place of x here, then it would be x minus h whole square plus b into x minus h plus c is equal to 0. So x minus h whole square equal to 0 is x square plus h square minus 2hx plus b into x is equal to bx minus b into h is equal to bh plus c is equal to 0 is going to be x square is square term and x terms are going to be, this is bx and this is minus 2hx. So you can take one x common remaining, b minus 2h times x, plus remaining terms are here h square minus bh plus c is equal to 0. This is what is the quadratic equation whose roots are increased by h. That of the roots of f of x is equal to 0. But that equation is given as x square plus qx plus r equal to 0. It means this equation is going to be x square plus qx plus r. X square plus qx plus r equal to 0. Then what are you asked? To find out the value of h. So where is the value of h here? When you will have to compare both of them, b minus 2h is coefficient of x and here coefficient of x is q. So you can equate coefficient of x in both the cases. So when you equate coefficient of x, here b minus 2h is equal to, here coefficient of x is q. Then b minus q is equal to 2h. Therefore the value of h is equal to b minus q divided by 2. This is the value of h. Did you understand? If the roots are increased by 2, increased by h, then the quadratic equation will become f of x minus h. Then when you compare both of them, the value of h is going to be b minus q divided by 2. Otherwise you can answer this problem in other way, that you will have to find out the quadratic equation whose roots are alpha plus h and beta plus h. How do you find out the quadratic equation whose roots are alpha plus h and beta plus h? Like the quadratic equation whose roots are alpha and beta is x square minus of alpha plus beta into x plus alpha beta is equal to 0. In that alpha is equal to alpha plus h and beta is equal to beta plus h. When you substitute them there, then you will get a quadratic equation in terms of h also. So I would like to explain that now. See, this is what is the value of h. Please do remember. And I am explaining the other way to answer the problem. So what is the other way? Alpha comma beta are the roots of this equation. Alpha comma beta are the roots of x square plus bx plus c is equal to 0. Then what is alpha plus beta? Minus b by a minus b by 1 is equal to minus b. Alpha into beta is equal to c by a, that is c by 1 is equal to c. Right? This is about the values of alpha plus beta and alpha beta. And what is actually the quadratic equation whose roots are alpha comma beta? That is x square minus of alpha plus beta into x plus alpha beta is equal to 0. This is what is the quadratic equation whose roots are alpha and beta. Now this is x square. The quadratic equation whose roots are alpha plus h comma beta plus h. In the place of alpha you write alpha plus h and beta you write beta plus h. Then the quadratic equation whose roots are alpha plus h comma beta plus h is x square minus, x means alpha means what? Alpha plus h, plus beta means beta plus h times x, plus alpha into beta is alpha plus h times beta plus h is equal to 0. Hope you understand. You just substitute alpha plus h and beta plus h in the place of alpha and beta. Then you get x square minus alpha plus beta plus 2h, alpha plus beta plus 2h into x. Alpha plus h into beta plus h is going to be, when you multiply both of them, alpha into beta is equal to alpha beta plus h into alpha plus beta plus h square, right, equals to 0. This is what is the quadratic equation whose roots are alpha plus h and beta plus h. Now you see here the value of alpha plus beta is going to be minus b and alpha beta is equal to c. When you substitute them, x square minus alpha plus beta equal to minus b plus 2h times x plus something is equal to 0. So why am I not writing that? Because this equation is going to be this, right? So when you compare both of them, then x square plus qx plus r equal to 0. Here x term is qx and here x term is this. It means qx is equal to minus of minus b plus 2h into x. Therefore, when you compare both of them, here qx is equal to this, so q is equal to, here it is negative, so negative of negative b plus 2h. Q is equal to negative of negative b is b minus 2h. Transpose minus 2h here and q that side. That implies 2h is equal to b minus q. Therefore, h is equal to b minus q divided by 2. This is what is the value of h in this way. So, any which ways, the result remains same. But what I personally feel that the previous method is most easiest method than this regular method. Right? Coming to the next problem. A quadratic equation cannot have more than dashed roots. See, for example, one of my quadratic equation is x square minus 5x plus 6 is equal to 0. If you find out the factors, you get x minus 2 times x minus 3 is equal to 0. Therefore, the values of x are 2, 3. So, 2, 3 are the roots of this quadratic equation. And I would like to write one more quadratic equation, that is x square minus 4x plus 4 is equal to 0. The roots of this quadratic equation are going to be x minus 2 whole square equal to 0, x minus 2 is equal to 0, so x is equal to 2 and one more is also 2. Here the number of roots of the quadratic equation is only 1, that is only the repeated root. So that is why in this case we do not say that the number of roots of the quadratic equation is 2. We will say only one root, but that is repeated. But here the number of roots of quadratic equation is 2. So there is a chance of getting maximum 2 roots of any quadratic equation. So it will not be more than 2. It will not be more than 2. So a quadratic equation cannot have more than 2 roots. Cannot have more than 2 roots. It can be 2 or less than 2. This is what is the example for less than 2. Hope you understand? Right. Coming to the next problem. If the product AC in the quadratic equation ax square plus bx plus c is negative. So AC is negative. Means AC is less than 0. Is negative, then the equation cannot have dash roots. See, we are not talking about what actual roots are. We are talking about the nature of the roots. So nature of the roots depends upon the value of delta, which is equal to b square minus 4ac. Right? AC is negative number. AC is negative number. Negative number is nothing but, for our understanding, let us say AC is equal to some minus 5. Since it is negative number. When you substitute AC equal to minus 5 here, b square minus of minus 5, which is going to be b square plus 5. What kind of number this b square plus 5 is? Since b is being any real number, then b square must be greater than or equal to 0. If b square is greater than or equal to 0, add 5 on both the sides, then it would be b square plus 5 greater than or equal to 0 plus 5. So what does it mean? The value of b square plus 5 should be greater than or equal to 5. It means delta value greater than or equal to 5. The discriminant is greater than or equal to 5. It means the discriminant is positive. Discriminant is positive. So then the equation cannot have dash roots, cannot have negative roots or imaginary roots. It can have only real and distinct roots. So cannot have imaginary roots and cannot have equal roots also. Okay? So cannot have imaginary or non-real, imaginary or non-real, and you can say that cannot have equal roots also. Cannot have equal roots. You can answer this blank by any one of these options. You understand? Don't get any confusion. Just to follow this AC less than 0. Right? Coming to the next problem. Like here, if the discriminant of a quadratic equation is greater than 0. So delta greater than 0, what kind of roots they are? If delta is greater than 0, then the roots are, say, similar to this case. Delta is greater than 0, then the roots are real and distinct. Distinct are nothing but different. So the roots are real and distinct. That is about the roots of this quadratic equation when the discriminant of the quadratic equation is greater than 0. Coming to the next problem. A quadratic equation ax square plus bx plus c is equal to 0 has two distinct roots, two distinct real roots. Distinct real roots if b square minus 4ac greater than 0. So your answer should be greater than 0. Or you can say that if the value of b square minus 4ac greater than 0, or you can say that positive also. Okay, so you can answer that blank with any one of these options. It should be greater than 0 or positive. Coming to the next one, a quadratic equation does not have any real roots if the value of the discriminant is, cannot have real roots means what? They are non-real roots or imaginary roots only when the discriminant is less than 0. Discriminant is less than 0 means discriminant is a negative number, then only it cannot have real roots. The value of k for which the equation 2x square plus kx plus x plus 8 equal to 0 will have real and equal roots. So real and equal roots means what? If delta greater than 0, they are real roots. Delta equal to 0, then they are equal roots. Real and equal roots means delta must be greater than or equal to 0. Right? What is that quadratic equation? 2x square plus kx plus x is nothing but, if you take one x common, it would be k plus 1 times x plus 8 is equal to 0. This is what is the given quadratic equation. Now, we'll have real and equal roots. Real and equal roots means delta should be greater than or equal to 0. So find out what is delta here. B square minus 4ac greater than or equal to 0. B is equal to here coefficient of x, that is k plus 1 whole square, minus 4 into a is going to be 2 and c is going to be 8 greater than or equal to 0. Right? So 4 2s are 8, 8 8s are 64. So k plus 1 whole square minus 64 greater than or equal to 0. K plus 1 whole square minus 64 greater than or equal to 0 can be written as k plus 1 whole square, 64 is nothing but 8 square greater than or equal to 0. It is in which form? A square minus b square is going to be a plus b into a minus b greater than or equal to 0. So k plus 1 plus 8 is equal to k plus 9 times it is k minus 7 greater than or equal to 0. So k plus 9 into k minus 7 greater than or equal to 0. Here k is equal to 7, here k is equal to minus 9. But since it is greater than or equal to 0, you please do remember one condition I would like to explain here. That condition is, if it is greater than type in equation or greater than or equal to 0 type in equation, then x does not lie or k does not lie between the roots. Does not lie between the roots. What does it mean? Here k value is going to be minus 9 and here k value is going to be plus 7. So x or k, here we are talking about k. K does not lie between minus 9 and 7. Does not lie between them. What does it mean? K belongs to, it should be less than or equal to minus 9 and greater than or equal to 7. So you can write it as minus infinite to minus 9 closed bracket union 7 to infinite. This is what is the solution for k. And this is what called interval notation. You please do remember this interval notation. If it is greater than type in equation, then k does not lie between the roots. Here the roots are 7 and minus 9. Therefore, that value of k does not lie between. If it is less than type in equation, definitely it should be lie between the roots. Understand? That is only the difference between greater than type as well as less than type in equations. Coming to the next one, the equation x square plus x minus 5 equal to 0, then product of its two roots is, what is the formula for product of roots? Alpha into beta, which is equal to c by a. C is equal to how much here? Constant, that is minus 5, divided by a is coefficient of x square, that is 1. So minus 5 by 1 is equal to minus 5. This is what is the product of roots of the quadratic equation. You understand? So these are the problems given for 1 mark, which are multiple choice questions or objective questions, whatever it is. But please be focused on the strategy in which I'm going to apply there in order to solve the problems. Different problems have different strategies, but how I am approaching the solution only matters, because carries 1 mark. If you answer this problem like to get 4 marks problem, time will be wasted. Since it is being 1 mark problem, you will have to think in such a way, how easily I get the answer. Hope you understand. Enjoy the class. Thank you.